Fab update, February 2nd, 2026. A lot of stuff has happened. I got the new RIGOL scope. It's pretty damn amazing. I've used it a lot and I feel a lot safer with it than with the analog discovery. It has a few quirks, like it's a RIGOL, so the UI is a bit quirky and sometimes crashes, but feature-wise it's amazing. I've used body plotting for analyzing filters, and the 4 high-speed channels are just pretty awesome. It has a lot of measurements and the web UI is really cool. This is a new scope. One thing that's annoying, the boot time takes forever. The fan always stays on, so you don't want to just leave it on all the time. It has a standby mode, which is pretty cool. So you can just set it to power sleep. And then from the sleep state, it wakes up a lot faster. Still takes a few seconds, but pretty good. You have the channels. To select them, you first tap them to turn them on, and then you tap them again for the channel settings. The annoying part is, that's also how the signal generator works. First need to turn it on to whatever is set to default, and then you can only change it. So we can see by default it's a 1 kHz 5V sine wave that's just getting blasted in your device under test. The only way I can see to not have that happen is by unplugging the cable. RIGOL, why? This is not good. The recommended workaround seems to be to just set basically 0 amplitude as your default. I think you can save your default somewhere. The logic analyzer needs an extra probe connected, which is kind of expensive. People have designed open source probes for that, but why not just make those things be the actual inputs? I guess I just wanted it to be an extra purchase, but at least that's not something you need to software unlock. Software-wise, it has like a lot of features. I am liking the UI. You can just click on things to add them, like the XY scope or photo plot mode. You get a lot of measurements, just a whole bunch of measurements from the vertical, the top height, the minimum, maximum, rise time, fall time, horizontal axis, vertical axis. This is pretty feature rich. I've used a lot of these and they work really well. It has frozen a few times, but that's just what you get with a RIGOL. Otherwise, it's overall pretty sturdy and I quite like it. We got the components for the G-EDM project from China, from LCSC. Sadly, I shipped them with DHL and they charged me with a ginormous import fee of like $90 almost, just for them to do a little bit of paperwork, which was quite disappointing, and I do want a cost analysis if ordering it even made it cheaper than ordering it locally with that extra fee, but it is what it is. This fee is in addition to the $50 they already got for shipping it and the $32 tax for importing it. This was not a fee I was expecting at all. A €120 package, no less. Like, that's ridiculous. The only options would have been to destroy my package or send it back. You just take your package hostage. We got the components now. We got also some PCBs from JLC PCB, and we got a handful of PCBs from the G-EDM creator. He sent me over unreleased Evo 4 pulseboard and an old Evo 2 motion board, so that gave me a bit of a head start because the PCBs only arrived like today. They're still sitting there on the incoming mail shelf. That's pretty awesome. I got the Evo 4 board. It has mostly minor changes, soldered jumpers instead of wires, removed the adjustable resistors, minor quality of life stuff. It took us like an afternoon to assemble the pulse board. This is moderately dense. We just hand soldered everything. We didn't even get a stencil since this is still the unreleased version. We also don't really have solder paste we liked, so if you have any solder paste recommendations or flux recommendations too at this point, I would highly appreciate that. I don't do a lot of production, so they would have to be shelf stable for a while. Doing this many components by hand is just kind of needlessly tedious, and just doing like hot air reflow or in hot plate soldering would make this so much quicker. We did a bit of switching with the pulse board and it looks pretty decent. It can definitely switch faster than I can measure current at this point. I probably need a higher bandwidth current probe. It seems to work as expected. Uses a pretty big beefy MOSFET driver and 4 discrete MOSFETs. So version 5 is gonna switch to a single large MOSFET. That part works pretty well. I had some issues with the sensing circuit. Now it's mostly stable. We're currently at 20 volts. I'm gonna turn this off and back on again. We are unstable again, and now I am going to put the inputs together and after they've been together once, they stay together. The signal path for the voltage and current sensing has a very unorthodox way of doing the optical isolation. Like, they're using a part in a way that wasn't really intended. So I got an oscillation at the last transimpedance amplifier, or what should be a transimpedance amplifier but isn't. Okay, so quick correction, I guess. It is technically a transimpedance amplifier, but it is not the zeroing type usually used for photodiodes, but one with a 100k resistor to measure the current. So that introduces a huge load on the photodiode, so you are all over the nonlinear regions. This is neither zero current nor zero voltage, and it just compensates for that nonlinearity by also having the same nonlinearity on the input side, which was just like swinging from rail to rail at 3 megahertz, which is not good. It didn't seem to have any actual issues in the software except for some noise. I'm trying to redesign that. We've implemented a few reference implementations for that analog optical isolator. It's a pretty cool part. It uses a matched set of photodiodes and an LED, so you basically build one transimpedance amplifier that servos the diode current and then expects the diode current on the other side to be closely matched enough. This part has very stable gain. This is like a pretty cool part with a bandwidth of up to a megahertz, and I've pushed it that far. I've implemented the basic transistorized circuit, which just uses 2 BJTs on either side, but this one isn't rail to rail, so that is a problem with the final isolated side connected to the ESP not having like rail to rail. It would have like 400 millivolts bottom limit, and that's just not really acceptable. We've thought about some ways of offsetting it, but all of them kind of suck. Adding an extra op amp at this point, you can just like build the version with op amps. Getting a negative rail in there would also skyrocket the cost. Offsetting it in software is both a waste of ADC resolution and also kind of adds extra complexity to the high-speed loop doing the signal reading, so that also sucks. That is not really something we want to touch. We also did the basic unipolar design with 2 op amps, and that seems to work pretty well. We got a version working now. It doesn't quite have the 1 megahertz bandwidth we were hoping for, but I think that's just passive selection. We're saturating the LED currents, need to limit further the photo currents we're expecting. We are also doing some research if all the other op amps in the signal chain are actually needed. I think a lot of them are redundant. We could probably just feed the 85 signal full scale into the first transimpedance amplifier and just have that working, but that's the next thing to investigate. Overall, that board seems to work pretty well, and it's a really fun challenge of debugging a lot of these analog circuits. Is something I rarely get to do, and the new scope is super handy for. We want to characterize actual linearity as well, so we get like actual figures. We don't need super high linearity, like the ADC resolution is somewhere in the 1-ish millivolts, so as long as we are within like half a millivolt or something, that should be linear enough for any stretch of the imagination. We also made a lot more PCBs on the laser. It has come in really handy, being able to quickly iterate on new designs. We used it to make breakout boards for breadboarding some of the schematics. We made adapters for different cables, like we have an adapter going from just DuPont connectors to BNC, so that's super useful for breadboards and just simple prototypes. Few iterations, probably like a board a day, maybe handful. We did notice there's some scaling issues, so we'll have to calibration. We don't have the calibration file from when the machine was shipped. We'll probably have to redo a full calibration, but for now we'll probably just do a scaling calibration and hope the boards turn out well. It is less of a problem with like independent stuff, but as soon as you have something that's supposed to plug into a breadboard, so you have distant headers, they no longer quite align to the breadboard, so that kind of sucks. But overall, it's absolutely amazing. We've gone through the first sheet of PCB material and now on the second, and it works pretty well. We do really need to figure out how to cut it out, since just using a chop saw for that is both kind of dangerous and very inconvenient. We've had small PCBs just get sucked up by the dust extraction, so that's funny, but also a bummer. So seeing if we can get it to cut out with a laser would be cool. Like, it should be possible. We should probably have fume extraction for that, because this material absolutely stinks. I've seen it work, so we should just develop a workflow. Also, I absolutely love Lightburn. I only switched from EasyCAD over to it recently, since it was just €200 software purchase. That seems a bit lot, but it's absolutely amazing. With EasyCAD, you had so much work just getting your designs ready because the vector import just absolutely sucked, and here you plotted in KiCad, you import it, and it just worked. works. You don't have to be connected to the laser for the software to work. You can just disconnect it, repair stuff upstairs. It's so much easier to use. I highly recommend getting Lightburn if you have a Galvo laser. It is just such a pleasure. We're gonna do more experiments on the feedback path. We should also probably start making tutorials on how the G-EDM works, as well as some of the parts we've discovered while that's still fresh, so hopefully expect some of those videos. On that note, we have expanded to 2 more platforms. We're now on Odyssey and also on MakerTube, which is a PeerTube instance, so federated social media, very cool. Odyssey has been an absolute disappointment. The YouTube import seems to only work if you have enough subscribers on YouTube, so that doesn't work, and we got absolutely no views on there. I don't think that's gonna be a platform we'll keep using, but MakerTube seems to work pretty well, and we really like federated social media. Like, we're a big user of Sharky, those Twitter-like things. We hope that takes off a bit more. We're getting less views than on YouTube, but not that much less. YouTube is barely giving us a few dozen views, so we'll probably post more there. Happy tinkering!